perfect and repeat, rational, perfect and repeat, rational, perfect and repeat, rational, perfect and repeat, rational. Anything other than that is irrational. 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 Perfect and repeat, rational, perfect and repeat, rational, perfect and repeat, rational, perfect and...
What's up, scholars? This is Mrs. Finney with Lyrical Math. This is our track tutorial for our song Be Rational. What you just heard is how to categorize a number as a rational number or an irrational number. The learning objective for this song is for you to practice reciting and memorizing what makes a number a rational number or an irrational number. Let's find out.
Perfect and repeat, rational, perfect and repeat, rational, perfect and repeat, rational, perfect and repeat, rational. Anything other than that is irrational. Anything other than that is irrational. Anything other than that is irrational. Anything other than that is irrational.
Let's check out what we mean by perfect and repeat, rational, perfect and repeat, rational. When we say perfect, we're talking about a perfect square. So here we have a picture of a square, and as you notice, all of the sides are 2 inches. And so in this case, when you're looking at a perfect square, it means that it's a whole number times itself, and that is going to give you a perfect square. So 2 times 2 gives us 4, so the square root of 4 is considered a perfect square. Let's think of another example. We can have 3 times 3, which will give us what? 9. And so the square root of 9 would be considered a perfect square. Next, we have end. When we say end, we're talking about a terminating decimal. Think of the word end means to stop. Terminating means to stop. So a terminating decimal means we have a number that comes to an end. It just stops. It's not going to continue to go on and on and on and on. It stops. So the digits stop. In 17.50, we have the last digit being 0. No questions about it. That's it. Last digit is what? 0. So this has a terminating decimal. This is a terminating decimal. 6.3, we would read that as 6 3/10 is also considered a terminating decimal. Which digit is the last digit? The 3. No questions about it. So this is considered a terminating decimal. Next, we could have a repeating decimal. So I have the example of 1/3. That's a fraction. If we divided the numerator 1 by the denominator 3, we would end up with a repeating decimal. Decimal 333333333333333333333. I could keep going, but I won't. So this line above is showing us that these 3's are going to keep going. They're going to keep repeating on and on and on non-stop. So a repeating decimal is also a rational number. So when we say perfect and repeat, rational, anything that's a perfect square, a terminating decimal, or a repeating decimal is considered a what? A rational number. Let's find out what makes something an irrational number. Here in the lyrics it says,
anything other than that is irrational. Anything other than that is irrational. Anything other than that is irrational. Anything other than that is irrational.
When we say anything other than that, we're talking about anything other than rational numbers. So, a rational number, we know we have perfect square, we have terminating decimal, and we have repeating decimals. So anything other than that would be considered a rational numbers. So a non-perfect square would be considered an irrational number. What is a non-perfect square? Well, we know a perfect square is when you have a whole number times itself when we're discussing a square, the space of a square. But let's think about this. If we have 4 times 4, that would give us what? 16. So we represent that with the square root of 16. If we have 5 times 5, that gives us 25. That represents the square root of 25. But check this out. There are square roots that fall between the square root of 16 and the square root of 25. all of them would be considered non-perfect squares. An example is square root of 17. It falls between two perfect squares. What about square root of 27? Do you think that's a non-perfect square or a perfect square? Square root of 27? Is there a whole number times itself that we can multiply together and give us 27? Nope. So that would be considered a what? Non-perfect square. So those are some examples of non-perfect squares. Next, we have non-terminating decimal. So if terminating means to stop, non-terminating means it's just not stopping. It's going on and on and on and on and on and on and on. The symbol pi, which is approximately 3.14159 ... I'm going to put that symbol approximately, meaning we're getting there, but we're not actually showing all the digits. So it just keeps going on and on and on and on and on. It's not stopping, so it's not terminating. Okay? Next, let's look at a non-repeating decimal. It's also considered an irrational number. I have a fraction here, 25 over 26. If I were to take that numerator, 25, divided by the denominator, 26, I would get this decimal that just continues to go on and on and on and on and on. It's non-repeating. Think about that. What does that mean? None of these digits are repeating. You notice we have 0.96153, and it just keeps going on with some random digits, so we would call that non-repeating decimal. So anything other than that, anything other than a rational number is irrational. Anything other than that is irrational. Thank you so much for joining me on this track tutorial. I will see you again. Peace.